All right, so this is going to be part 2 of 2-6. So 2-6 part 2. And we're going to start off talking about vertical asymptotes of rational functions. So we saw in this example from part 1 that we have this vertical asymptote at 0. And we're going to look at the patterns for finding vertical asymptotes. Now the roots, or the factors, or the zeros, whatever term you want to use, of our denominator are the vertical asymptotes. Except if they cancel with the numerator, then they're wholes. So there's a lot of terms right there. There's vertical asymptotes and there's wholes. Okay? Wholes are if the factor cancels, and vertical asymptotes are if the factor does not cancel. All right, now that's how we're going to determine whether it's a vertical asymptote or not. This will be a lot easier to see in the next examples, so let's do a couple examples where we have vertical asymptotes. Okay, so here we have some polynomials or some rational functions here, and we want to determine, find all the vertical asymptotes if there are any. There may not be any. Okay, so again, we're looking at what makes the bottom equal 0. That's what we want to look at here. So looking at these examples, in the first one, what's going to make the denominator 0? Well, first we need to factor, and none of the factors cancel with the numerator. So that means we have a vertical asymptote, and I will always write VA. I'll never write vertical asymptote. So if you see VA, that means a vertical asymptote. And we have a vertical asymptote at x equals 1 and at x equals -1. Okay. Now looking at the next one, we can factor again, and thankfully it's the same as the previous example. And we can see here that this factor cancels out. And that means that x equals 1 is a whole. And that leaves x equals -1 as a vertical asymptote. Okay. Now looking at this last example here, I can't factor the denominator, at least not with real numbers. I would need imaginary numbers to factor this. And so what that means is that there's no values that make my denominator 0. You can try to think of some x values, but there's none that are going to make this equal 0. So since there's nothing that makes the denominator equal 0, there are no vertical asymptotes. Okay. Now that's just talking about vertical asymptotes. But what about horizontal asymptotes? Because we saw that in these examples too. Right here, we also had a horizontal asymptote, and so we need to think about how do we find what those are. Now, this is a little bit more challenging. There's a little bit more to how we find horizontal asymptotes. If this is just be any rational function here, then what we're looking at here is these leading terms here. This is what we want to look at right here, okay? We don't care about the rest of the terms here. We care about the biggest degree, all right? Now, if the degree of the top is bigger, okay, actually let's talk about if the degree of the bottom is bigger. So if the degree of the bottom, m, is bigger than the degree of the top, so let's say bottom bigger, okay, so here the bottom is bigger, then that means the x-axis, or the line y equals 0, is our horizontal asymptote. Okay. Now, if the degrees are equal, so degree equal, then the line of their leading coefficients, a sub n and b sub m, that's going to be your horizontal asymptote. And if the degree of the top is bigger, then what that means is that there's no horizontal asymptote. Okay? Now let's go back to this paragraph up here. Let's talk about this for a second. It says, recall that a rational function may have several vertical asymptotes. So we can have several vertical asymptotes. By contrast, it can have at most one horizontal asymptote. So either 0 or 1. There's no more than one horizontal asymptote. Okay. And although a graph can never intersect a vertical asymptote, so a graph can never intersect a vertical asymptote, it may cross a horizontal asymptote if the graph, it may cross the horizontal asymptote. So there may be times where your graph does actually cross your horizontal asymptote. And usually that will be when you have two vertical asymptotes. And we'll see some examples of this happening in our homework and in class. Okay. So let's go ahead now that we've figured out how to find our horizontal asymptotes, and let's practice finding them here. Okay. So looking at our first example here, find the horizontal asymptote, and we're going to be using this information that we're seeing right here. So I'm going to try and keep all of this in my screen here. So this bottom example here, the degree of the bottom is bigger than the top. So the bottom is bigger, which means the x-axis or y equals 0. Same thing. So that's our horizontal asymptote. And looking at the next one, well, now my degree of the top is the same as the degree of the bottom. So we're looking at those leading coefficients here. Let me zoom in on this one for just a second. So since the degree of the top is the same as the degree of the bottom, then it's the coefficients here. So that means my horizontal asymptote is y equals 4 over 2 or y equals 2. Okay. And then for this last one, the degree of the top is bigger. And looking back at what we said, if the degree of the top is bigger, then there's no horizontal asymptote. Okay. And I'm going to go ahead and flip the page now. And looking at the next page, it's saying using transformations to graph rational functions. And you'll notice that we have this on Schoology. If you look at the graphs that I showed you that I made on Schoology, that can help you here as well. So looking at our graphs here, we can shift our graphs up and down, left and right, and we're going to look at how that works here. The general form, which is also on Schoology for you guys, of a rational function is f of x equals a over x minus h plus k. Okay. That's just the basic rational function. And then if we have the square function, then that would be f of x equals a over x minus h squared plus k. And just like every other graph you've seen before, h is what shifts it right and left, k is what shifts it up and down, and then our a value can either stretch or shrink or flip our graph over. So on your quiz and on your test, I'll expect that you guys are able to do these graphs without your graphing calculator. You won't have that. So make sure that you practice how to graph this without your graphing calculator. On the Calculus AP exam, they also expect you to be able to graph without your graphing calculator. So let's go ahead and draw this graph. We have 1 over x squared. Okay, and I'm going to do this one in pink here. So 1 over x squared, we already graphed that, so I'm just going to go ahead and draw that graph out since we already have that. All right, and then we know that we have a vertical asymptote at 0, horizontal asymptote at the x-axis. So that's just this function right here. Now we are going to graph the function that we see right here. But first let's describe what's happening with that graph. If this is a minus sign in here, we're shifting to the right 2. If this is plus here, it does exactly what we think. It's going up 1. Okay. So everything, including my asymptotes and everything, are going right 2 and up 1. And there's more than one way to graph these, but I like just shifting everything. So let's start with the asymptotes. If I have my horizontal asymptote here at the x-axis and everything is moving right 2, well, that's not going to change anything. But going up 1 is going to change things. Now that's where my asymptote is. And for my vertical asymptote, going up and down isn't going to change anything, but it is moving to the right 2, and that does change where it is. So there's my asymptote. And my graph is going to do the same thing. It's going to shift everything. So I can move all of these points to the right 2 and up 1. So that's exactly what I'm going to do. I should see this kind of detail on your graph as well. And same thing over here. And that's how we can use transformations in order to graph our new rational function here. Okay. Now, at the bottom of this page, it says graphing rational functions that are not transformations of one of these two. Now, on the next page, we're going to look at a procedure for going through graphing just random rational functions. These are the nice ones. The ones we're about to look at are not as nice. I'm going to go ahead and cut this video right here, and so this will be the end of Chapter 2, Section 6, Part 2, and then the next video will be Part 3.